Okay, assessment review. Find the value for C. Here's the first problem. Okay, every problem's got its own unique direction. So, find the value for C that creates a perfect square trinomial. Then rewrite the trinomial in factored form. Again, find the value for C that creates a perfect square trinomial. Then rewrite the trinomial in factored form. Okay, so we have learned before that C is equal to B divided by 2 to the second power. Now B is 10, negative 10, excuse me. So then that's negative 5, and then negative 5 to the second power means negative 5 times negative 5, and that's 25. So C is now 25, okay? And then we need to write it in factored form. So A is the implied 1, B and C. Okay, and then 1 times 25 is 25, positive. So the signs have to match, and it has to add to negative 10. So the matching signs would be a negative. Now, when you use B divided by 2 to the second, the factors are the same. So what times itself gives you 25? It's 5, okay? So you can ditch the A, make two parentheses, x, 5, 5, and then minus, minus. Now, I didn't leave myself a lot of room, but you need to write that as x minus 5 squared, and that's your answer. Okay, my second one. Convert the equation from standard form to vertex form. Standard form to vertex form. So standard form to vertex form is when I write the y out 3 times, okay? Okay, so, and what I always need to do is make a parentheses, kick out the minus 40 and put 1x second. Now the rest is, does that match this? It does, so we can carry down minus 12x. So I've got A, B, and I got to find a C myself. 40 can't work. So B divided by 2 to the second. Okay, so B is negative 12. Negative 12 divided by 2 is negative 6 to the second. And negative 6 times negative 6 is 36. Okay, so plus 36. Now, we brought in a 36, so I'm going to write that off to the side. Is there a number out front here, the parentheses? There's not, so it's just 36. So I have to add 36 to the other side of the equation, but I can't add 36 to y, so I need to now minus 36 and then put that with the minus 40. Okay, I need to factor that. 1 times 36 is 36, so 36 positive, the signs have to match. And we're adding to try to make negative 12 out of it, so I would want 2 negatives, and it's always the same number. So what's the square root of 36? 6. Okay, so minus 6 it is. So I can ditch the 1. X minus 6, x minus 6. And then negative 40 minus 36, okay, is going to be negative 7 minus 76. So now I just write it as, sorry, I'll drop that down. Y equals x minus 6 squared minus 76. Okay, and there you have it. Okay, the next one, the directions are the same. Convert the equation from standard form to vertex form. Okay, so we make a parentheses, we kick set. You got to know the setup for it. That's the setup, what I just did. Okay, and you need b over 2 squared, and then the t chart. Because b over 2 squared finds our c. However, this 1 does not match this, so we don't just drop 30. We need to factor 5 out, just 5, not 5x. So, okay, because I want the x's to stay the way they are, and 17's already been kicked out of the group. So I bring 5 out, and I got 1x squared minus 6x. So that's A, that's B, plus, and I have to come over here and find a C. So I take negative 6, divided by 2 to the second power. It's negative 3 to the second. So negative 3 times itself is 9. So I bring in 9. Now I'm going to write 9 off in dreamland here, okay? And there's a 5 out there, so I didn't bring in 9. I brought in that side of the equation, 9 times 5, and that's 45. So it's 45 I brought in this side, so I have to add a 45 over here. But everybody knows you can't add 45 to y, okay? So you minus 45, and then not put it with the 17, okay? Now, I rewrite this into 2 parentheses, factored form. 1 times 9 is 9, positive. So the signs must match, and given the fact that they have to add to negative 6, they have to be the same number, 3, 3, okay? And that's it. And we can ditch the 1. So x minus 3, x minus 3, and then 17 minus 45 is minus 28. And then you'd have 5, x minus 3 to the second, minus 28. Okay. Alright, find the value for k that makes a perfect square trinomial. Okay, so what we're really finding is what the b is this time. Now, to find b, you take the square root of a times c and then later multiply it by 2. Okay. It's like the opposite of the second power, which is a square root, and then you times by 2 instead. It's like you're going the opposite direction. See, the last thing I did here was second power, so I square root, and then I do the opposite of divide, which is times. It's kind of like this going in reverse. So 1 times 9 is 9, so this is going to be 9, and the square root of 9 is 3, and then 3 times 2 is 6. You just need to put k equals 6. That's all you got to put. Okay, this is a gimme. Evaluate I to the 8th power. Now remember, I to the second equals negative 1. So what we're going to do is split that up into groups of 2. So I to the second times I to the second times I to the second times I to the second. So all those are negative 1s. And then multiply them together. You're going to get 1, obviously. It's going to be positive 1 because you have an even amount of factors. Now, if there was an odd amount of negative factors, the product would be negative. Okay, number 6, simplify. Now, what operations do we have? Well, we got a minus. We got a plus in between. Got a plus, so it's all plus and minus. So I just go blank plus blank I, and we want plus. We don't want minus in between. If we have minus, we have to change something. But I'm good with plus, so the non-i's, I have 4 and 2. I combine those to make 6. And the i's, negative 5 and 10, make 5. There you have it. Okay, now, the next problem. And also remember, if it's a minus, you got to make it plus, and these go opposite. Other than that, having a minus would be the same. Okay, this one right here. Well, we got a minus, we got a times, and a minus. Okay. Now with the times, we need to do some work over here. How many terms do you have in each parentheses? You got 2 by 2. Well, that's going to make a FOIL. 8 times 8. 8 times negative 1i, yes, it's negative 1i. Negative 6i times 8. And then negative 6i times negative 1i. So that gives me a 64, that's in simplest form. Negative 8i, that's in simplest form. Negative 48i, that's good to go. And then 6i to the second, that's not in simplest form because I second equals negative 1. So 6 times negative 1 is negative 6. Now it's in simplest form. So we combine the constants and we combine the i's. Usually it's the constants before i's, but if you do the i's first, that's fine. So 64 and negative 6 combine. I add them. They would add to 58. And then negative 8 plus negative 48 is negative 56. Okay, now what do I typically do when I have a second power? Well, you just duplicate the parentheses, 7 plus 5i. Now, you don't make it minus. That's not this problem. When it's a second power, it's exactly the same. The same two terms, the same sign. There is a problem later where you need to make the sign a minus, but not with a second power. It's got to be identical, exactly identical. So that has two terms, that has two terms, that's another FOIL. Okay, so that's four products we find. So 7 to 7, 7 to 5i, 5i to 7, and then 5i to 5i. So that equals 49, that's 35i, that's 35i, and that's 25i to the second. Now these are in the bank, okay? This one's not, because I squared is negative 1. So 25 times negative 1 is negative 25. Okay, so blank plus blank I. So 49 plus negative 25 is 24. And then with the i's, you have a 35 plus a 35. No, those don't cancel. That's when you have a 35 and a negative 35. That adds to 70. Okay. Now, find the quotient. That's what you're thinking, okay? You can't divide, okay? You're not ever actually going to divide, okay? You are going to make a second fraction. And now to know what you're multiplying by, you got to count the terms. This has 2, but this one just has 1. And you look at the bottom, it's all about the bottom. If you just have one term on the bottom, you're just going to times by I. Now, can you put a 1 in front of the I? Sure. But if you put, because remember, what you're trying to do is get the I out of the bottom. Okay? Because you know that I squared then goes to negative 1 and you won't have it. Okay, so we got to find our top and our bottom. So if you put, even if you put 1 in front of the I, it's still just one term, okay? 2 terms by 1 term. Put the 2 in parentheses, okay? So that's 2 products we have to find, because 2 by 1 would be 2. It's like timesing. That tells you how many products you need to find. So we take 8 times I, or 1i, it doesn't matter. If it helps to put a 1, do it. Then 7i times I. 8 times I, or 8 times 1i is 8i, simplest form. 7i times I would be 7i to the second, but that's not simplified, because I to the second is negative 1. 7 times negative 1 is negative 7. Now we're good. So in the top, we're going to have negative 7 plus 8i, or 8i plus negative 7. It doesn't really matter. That's how the textbook does it. Okay, now on the bottom, we got a 1 by 1. Well, that's just one product. So it's 2i to the second, but once again, I to the second is negative 1. So that product needs to be simplified further. 2 times negative 1 is negative 2. That's all we're going to have on the bottom. And there it is. Okay, number 10. Top, bottom. My answer will go here. Okay, how many terms you got on top? 2. So that goes in parentheses. How many terms on bottom? 2. That goes in parentheses. Now look at the bottom. What we multiply by is based strictly on the bottom. There's 2 terms. So when there's 2 terms, as opposed to 1, just multiplying by I is not going to cut it. Okay? You have to use the conjugate method, which means I put the same 2 terms, but I switch the plus over to a negative. And that'll still be 2. And then the top matches this bottom here. Okay? So on each side we're doing it 2 by 2. So 3. 3 times 9. 3 times negative 2i. Then negative 4i times 9. And negative 4i times negative 2i. So 27 negative 6i, negative 36i, and 8i to the second. Now the first three are good to go, but that I to the second is negative 1. That's negative 8. Okay, so 27 plus negative 8, you can combine those and those two. So if I add 27 and negative 8, that's going to be 19. Then negative 6 plus negative 36 is negative 42. Now the more important thing's on bottom, because that's where the I goes away. So we take 9 times 9, 9 times negative 2i. Remember, the i's are going to cancel, as you'll see here in a bit. Then 2i times 9, and then 2i times negative 2i. So that's 81, negative 18i, positive 18i. So I got a negative and positive of the same product, so those cancel. They add to 0. So 81, and then negative 4i to the second, but that's not simplified because we know that I to the second is negative 1. And that's 4. So 81 plus 4 gives me 85. There you have it. Okay. Okay, now last two, you're solving equations, quadratic equations, where complex solutions are going to come up. Okay. So as like any quadratic equation, we got a and then two c's. So a c's, if b's not here, okay, you just get the x squared by itself, and then you're going to apply the square root. Okay, so I add 3. Oops, sorry, I don't want that to be a negative 40. On your paper, I think it's positive 40. That needs to be negative 43, please. Negative 43. It should have said 2x to the second minus 3 equals negative 43. So I'm going to rewrite that. This isn't going to do what I want it to if... There you go. Still an a and two c's. So you add 3, and that's negative 40. Then you divide by 2, and you get negative 20. Now x squared's by itself now, okay? We just need to apply the square root to get rid of the second power. Okay, so a negative means I need to bring I out, and then go to my perfect square list, okay? And see if 20 divides by any of that. It's not here, so I'm going to divide it, okay? So 20 divided by 16 is a decimal. 20 divided by 9 is a decimal. 20 divided by 4 is 5, okay? So I put 4 and 5. Because 20 is equal to the square root of 4 times the square root of 5, but the square root of 4 is actually equivalent to the whole number 2. So I got 2 square root of 5, and I got to put the I in between them, okay? So I have my answer. 2i square root 5, but you could also have negative 2i square root 5. Those are your solutions. Okay, the number 12. 3x to the second power minus 5x plus 8 equals 0. So two answers. This time we have A, B, and C. So we make sure we're at 0, then we apply our discriminant to know the next direction I should take with it. So B has a value of negative 5. 4. A has a value of 3. C has a value of 8. Okay, b squared minus 4ac. So b squared minus 4ac, b squared minus 4ac. Okay, then drop your minus. Negative 5 to the second, that means negative 5 times itself, that's 25. Then 4 times 3 times 8, it's going to be 96. Now again, I should have punched it in on my calculator first, okay? Kind of jumped the gun a little bit. So I got domain error, so then I proceed with actually evaluating, because I know I'm going to have to use an I. So 25 minus 96 gives me negative 71. Okay, then I extract the I out. 71 is not a perfect square, so I divide into it. Decimal, 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 and decimal. Okay, so that's it. But you don't, that's not your answers. You have to go to the overall quadratic formula. Opposite of b plus or minus d square root b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So you're going to have 5, negative 5, and then 4, a is 3, c is 8, and on bottom a is 3. So you know you got 5 in front. 2 times 3 is 6, and that square root, kind of already figured that out. It's I square root 71. If you want to put a 1 in front of it, go for it. Okay, your adding and minusing is blocked by both the I and the square root. So if you have either one of those, much less both of them, you can't add those. So that's your answer. 5 plus 1i square root 71 over 6. And then 5 minus 1i square root 71 over 6. Those are complex solutions, okay? So are those.